Okay, so in 17.2 we worked with the law of sines, okay, which to work with the law of sines, what do you need to know? Like what pieces of the triangle must you have?
The hypotenuse and something else.
Well, remember that we're working with an oblique triangle. Okay, so okay, let's use sides, angles, sides, like side angle side. You definitely need at least one angle. And which side specifically? The opposite side. Okay, so to use a law of sines, probably a very good blanket statement for that would be, as long as I know an angle and its opposite, I can use a law of sines. Okay, so if you didn't write that down in your notes initially, law of sines is an angle and its opposite. Okay, law of cosines is also solving oblique triangles. Okay, so this is a scenario where you might not have an angle and its opposite. Okay, so the first part of this goes through how they come up with the equation for the law of cosines. I'm not going to show you this today. I think that it's pretty cool, but I think that you might kind of get lost in it a little bit initially. So I think I might show that to you on Wednesday. I would rather have you focus directly on the exact law. Okay, so here's the law of cosine. I will let you write this down. If you want to draw the triangle, you can. It is not necessary. The reason they draw it is just labeling the triangle.
We're just taking the hypotenuse law, subtracting it from a new law.
Pythagorean's theorem?
Yeah.
They do use Pythagorean's theorem to derive the law of cosine. So it is actually a combination of Pythagorean's theorem and a sine ratio. So sine being opposite over hypotenuse. So I will show it to you guys on Wednesday just so you can see it. And it's not incredibly magical like some things are derived, but a little magical.
So so as math goes, there's usually a simpler way of doing it. So is there a simpler way of doing all these different logic?
Usually what I give to you is the simple way of doing it.
Oh, okay. I was just
So math is basically this idea of, can I come up with a trick in order to solve this equation or whatever it happens to be doing. So that's where all these theorems, so all these people thousands of years ago have developed these super cool laws that we can use today to make things simpler. So all right. Did everybody finish with that? Okay. One thing I would like for you to add on this, we're going to actually call this the law of cosines number 1. Okay, so there's 2 laws I'm going to write for you. It's technically one law, but I'm going to manipulate it so that it's easier to work with depending on the scenario. So this law you would use if you are given a side angle side. SAS, yeah. If you have a SAS, you will use a law of cosine. Okay. All right, so we need an example. Let me steal an example over here. Here is a nicely drawn triangle. Whoa, nicely giant triangle, okay. Okay, so we'll do, we're still working with the same idea. So this entire module 17 is simply solving triangles. So the ability to find all the angles and all the sides of any kind of triangle is what this is all about. So we're gonna solve the triangle. Here's your example 1. Okay, so before I start, what is given to me in terms of sides and angles?
You're given the angle C, the side of AB, the side of BC.
Okay, so we are given a side angle side scenario. Okay, so that tells me I'm going to use my first law of cosines rule. Okay, so which side am I going to use? So of those three formulas that you wrote down, which one am I going to use? The b squared. Very good. Okay, so it's always easy to identify because it's the one that's always opposite of the angle. Okay, so everybody looking at that b squared equals formula? Because I'm not going to write it down, I'm just going to plug in the information. Okay, so it goes, it is equal to the a squared. So what's my a squared value? 7. So it would be 7 squared plus 5 squared minus 2 times, I'm going to write 7 times 5, not that it matters at all, times the cosine of the b. Okay, here's the trickiest part about the law of cosines. Typing it into the calculator correctly. So let me show you how I do it so that you don't mess it up. Okay, so the way I do it is I type it all in as one single line. Okay, basically exactly as I see it. Okay, so I'm going to type 7 squared plus 5 squared minus 2 times 7 times 5 times the cosine of 100. Okay, so if I hit enter, did anybody else get 86.2? Okay, so is that my side B?
No,
Okay, good. It is equal to the square. So I have to square root this. So square root of, I'm just going to go up, hit the up arrow and hit enter. That way I'm using the exact value. Okay, and side B, everybody agree that that would be 9.3. Awesome?
Awesome.
Okay, so where would you go from here to keep solving this triangle? We are now looking for angle A or angle C. Okay, good. So now we're going to go back and use a law of sines to finish solving this triangle. So we have an angle and its opposite, so we have the b's. So we'll set up that ratio first. So we'll have the sine of 100 over 9.3. Do you want to find A? Okay. So then it will be the sine of A over 7. 7. All right, so since you're looking for an angle, make sure that you cross multiply, and then what will you be doing last when you look for an angle? Inverse, right? So I'll let you guys calculate that while I do my power. 47.8. Anybody else concur with that? Anybody disagree? Okay, so I have two angles, excuse me. So how can we easily find angle C? Yeah, let's use the interior angle theorem. 180 minus 100 minus 47.8, that's going to be a small number. What is it? 32.7. Perfect. What? Oh, 2. Where did I get 7 from? Wishful thinking. My bad. So, do I need to do another example when you're given a side angle side? Pretty straightforward. Okay. The second equation comes from the idea of getting 3 sides, so a side, side, side. So I'm going to show you how they come up with the second formula. You don't have to write it down. It's completely up to you. I'm just going to use the first formula to manipulate it. Oh my gosh, I got an itch. Okay, so
I'm going to use the...
There is no law of tangent, believe it or not. Oh, I'll show you.
separately.
So, okay, so did you notice that all three of those formulas were like really exactly the same? They just switched the variables around just depending on which side you were looking for. Okay, so let's say I was trying to find the angle first. Okay, so in the scenario of given a 3 sides, how can I come up with the angle? Okay, so algebraically what I'm asking you to do is how would I take this equation and solve for the cosine of A? How would you isolate the cosine piece first? Okay, good. You would subtract the b squared and subtract the c squared, right? So it would be a squared minus b squared minus c squared is equal to negative 2 times b times c times the cosine of A. Okay, how would you then get rid of the negative 2bc? You would divide by negative 2bc. BC. Oh gosh, no. There's a big fat plus sign and a big fat, well actually they're both minus signs. So, sorry. So the cosine of A is going to equal a squared minus b squared minus c squared over negative 2bc. Now what I'm going to do here is, there's a lot of negatives going on, so I'm going to divide by a negative. Are you ready for this? And this is the formula that you should write down. B squared plus c squared minus a squared over 2bc. So this is the one that I have memorized. Okay, so do you see how I went from the step prior to the second one? Just pulled out a negative out of every single term. I always like to subtract last. I also remember that if you're subtracting a side, it's always the side that's opposite of the angle that you're looking for. So it makes it easy to remember. Okay, so the second formula that you would write down, so the one that correlates with the different variable, if we're looking for angle B, you would do a squared plus c squared minus the b squared over 2 times a times c. Okay, so this one is incredibly easy to remember because the two sides that are adjacent to the angles are always the positive ones on the top. They're also the ones that you divide by. Okay, so if you even want to go as far as using one off for angle C, a squared plus b squared minus c squared over 2 times a times b. Okay, so we're going to call this the second law of cosine.
Do they both do the same thing, or do they both do 3 different? Like they answer the same?
This is the scenario if you have a side, side, side. So if you're given a side, 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 you use the second law.
Okay, gotcha.
It is exactly the same equation, it's just I have solved for different pieces of it. Okay, so this will just kind of save you your time when you're solving your triangles. Everybody good? It's really funny because when I'm teaching with Math 3, I shouldn't record this, but it takes like 20 minutes for them to write things down. So I'm always like, it takes forever. So I'm always shocked at how fast you guys can write stuff down. Okay, so here is an example for our second law. Okay, we are given the 3 sides. Would you guys like me to draw a picture for this?
Yes.
Okay, so naturally assume that I draw nothing to scale. The C is the longest side, so I would say A is 35, B is 42, and C is 50.3. Actually, that looks pretty good. Alright, so the first thing I have to do is choose which angle I'm going to solve for first. Okay, so it doesn't matter, you choose. We are going to solve for That was a question. A, thank you. Okay, so we're going to use the cosine of A definition that you wrote down. So cosine of A. Okay, so I always look at the triangle and I think, okay, well, A is going to be, if I add my two adjacents, so the ones that are next to it will be 42 and 50.3. So it'll go 40 squared plus 50.3 squared, and then you always subtract the side that's opposite. Yeah, did I not say that? Oh, you're right, sorry. I even wrote 40. 42 squared, thank you. I would have got the wrong answer. And then you divide by the two sides that are adjacent. So 2 times 42 times 50.3. Okay. So, again, vital piece of this is typing this in the calculator correctly. So I'm going to show you how I would do it. Now, this is not the only way, but of course it's the best way because it's my way.
Consistency.
Okay. I'm going to, again, type it exactly as I see it. I'm going to use the fraction button so I have a top and the bottom. Okay, so I'm going to hit alpha y equals and enter on number 1 and type exactly what I see. So I got 42 squared plus 50.3 squared minus 35 squared. Downstairs I have 2 times 42 times 50.3. Whoops. 0.3. Oh my gosh. Times. Come on, little calculator. Okay, so when I do that, I get 0.73. So is that angle A?
No.
No. Remember, if I'm looking for an angle, what do I have to do? Inverse. And notice we're working with cosine, so it's going to be inverse cosine of the angle. So did anyone else get 43.4 degrees? Okay, good. So A will be 43.4 degrees. Okay? Yep. I probably on this section will only round to the 10th. If you round to the 100th, I would not ever mark you wrong. So if you are more accurate than the actual answer, then you're fine. All right, so where would you go from here? There's a couple options. We have 2 options, actually. What's that? Okay, so are you saying law of sines?
Yeah.
Oh. Okay. So, yeah, you can choose. You can do another law of cosines and do it off of B, or we can set up a law of sines because now we know the A's. So, which game do you want to play? Law of sines or law of cosines?
Cosine.
Cosines? Oh, okay. What? No, that's fine. Whatever, I was just surprised. Law, okay, so cosine of B, so if we go from B, what is that, 35? So we're going to go 35 squared plus 50.3 squared minus 42 squared. Holy cow, my pad is super hot. 2 times 35 times 50.3. So, did anybody do this already? Or should I do it? Oh, you already did? What'd you get?
55.6.
55.6. Anybody concur with that? Seems right. It's slightly bigger than the A, which should be. Concurred? Super. All right, so how do we easily find angle C? Yeah. Interior angles, 43.4 minus 55.6, and you get
A whole 81 degrees.
80 what?
Well, 81.
Exactly 81. Oh, nice. So what do you think about law of cosines?
I mean, if you're doing the calculator correctly, it's probably faster than sin or sine.
Yeah.
But I mean,
They're pretty close,
they're
really.
pretty close.
I mean, as long as you set
It's
it
a
up and type it in
preference.
correctly, yeah. One thing about the law of cosines, so you know how the law of sines has that potential for the second triangle? Law of cosines has no potential for law of the second triangle. So when you're using law of cosines, you just go for it. Okay. All right, that's all I got for you guys.